The genie of the AI lamps just fulfilled one new wish. We wonder how to interact with models from Hugging Face. Let's discover the magic. Okay, let's start and play with Hugging Face. First, some prerequisite to be able to execute Node.js code into this Jupyter notebook. So this is a helper function. Then I will install some npm package to be able to manage environment variable, to use the official binding libraries from Hugging Face and the LangChain framework. And while it is installing in the background, let's introduce Hugging Face itself. So basically, it's an AI startup and a community around it, developing and providing state-of-the-art AI and NLP models and API for various applications. And its objective is to make accessible and user-friendly everything for developer, researchers, and businesses by offering pre-trained models, libraries, and easy-to-use interface. If you go on the website, you can see there are a lot of models available, almost 500,000 here. So you can reuse the model, use them if an interference endpoint is provided by Hugging Face. You can even directly call the model. That's what we do. Or we can retrain them, fine-tune them. You can also reuse datasets that are shared and provided by many actors. You can you have communities and discussions, and also, as I mentioned, you have inference point. So some are free to use. And if you want more professional or industrial endpoints, you can pay for it, depending on the hardware that you choose. Okay. So to be able to make my demo, I will need to have an account that I already created here. And from this account, you can set up an access key. So if I go on settings here and I go on access token, there I created access token. The content of this token, I will copy and store in a .env file. So back to my demo here. What we'll do is we'll use the .env npm package to store and load in memory the access token. So let's do it. I already copied my token in the .env file under this entry. So I load this in memory. Here we are. And then about the demo, so the different abstraction level that we discussed in the previous video already, we'll do 4 different demos. The first one is direct API codes. Then we'll use the Hugging Face libraries. At level 2, we'll use the LangChain framework. And at level 3, we'll use the no-code Flowise solution to do everything without coding any single line of code. All right, so the first level is to make first simple API calls directly to a model. So the model I choose is Falcon 7B Instruct. It's a model provided by TII from the Emirates. And what I like is it's a mixture of chat and instruct datasets, so we can use it to chat. If you look at here, for instance, you can compute the inference API. All right. So the model is loading right now. You see, because it's the free offer from Hugging Faces, so you need the model to be loaded into memory and the endpoint to be available to do your test. So it's good that it's loading, so we'll be able now to test it. So you see here, you have the result. So let's do it now from an API call. What I do is I call with a fetch command the endpoint from Hugging Face with the model within the URL, and then in the headers I will pass my access token right there, and then I wait for the answer and display the interesting part of it. And I want to know how to say hello in Thai. So if I run this code right now, okay, so let's run the code, and here's the answer from Falcon, right? How to say hello in Thai. We can do the same with embeddings. You remember, embeddings is a way to transform natural language in text form in a mathematical object called vectors. And then we'll use those vectors to do some semantic research and implement the RAG pattern. So there I choose this model from BAA, the BGS model for English language model. Here again, I will call the model with the fetch command, pass the access token again, and I want to translate this sentence in a mathematical object. So let's run the code. Here we are. So here we have the result. It's a vector of 384 dimension, all right, which is the expected from this model. All right. Now, if I move up the abstraction level and I go to level 1, now I want to use the Hugging Face Node.js library. So what I'll do is require the inference part of the package and then create this object, pass the token as a parameter, and just code this function. So the code is more concise, as you can see. And I code text generation with the model and the input as parameters. Then I run the code. And now I know how to say hello in Japanese, which is konnichiwa. All right, same thing for embeddings. Basically, I call the same stuff, but this time I call feature extraction. And here you have the same vector that as before. Okay. Now, if I move up level 2 of abstraction, now I want to use the LangChain, well-known LangChain framework. That is a AI and LLM app oriented framework in this JavaScript version. So what I do is require the necessary object from the package, and I want to do some Hugging Face inference. So I instantiate this object. Again, I pass the model name and the API key as a parameter, and then I'm able to call the function. I just wait for the answer and display everything. Let's run it now. Here we are. So hello in Spanish is hola. Same thing with embeddings. So basically, now I want to use this object, Hugging Face inference embeddings, with the same model that we used before also. And then when I try to embed this sentence, what is the result? There we go. Again, the same vectors. Okay, so we did play and with embeddings, I get again vectors, but what to do with them? It's useful, for instance, when you want to implement the Retrieval augmented generation pattern, which is a way to inject a custom element of information within the prompt at runtime for the LLM to be able to make contextualized answers. Let's see how it goes with our 384 dimension vectors. So what I'll do is I load a PDF file of mine that is on my hard drive, and then I'll ask LangChain to deal with it. So cut it in different chunks, transform the different chunks into vectors, get the vectors and store them into a memory vector store. Okay, and then with the Retrieval QA chain, that is a predefined workflow within LangChain, be able to implement the right pattern using the model, so the model we created already, the vector store that we just created here, and I want to return the source document used to make the answer to be able to see how the LLM made on what element or customized element it made his answer. So now if I ask the question, what are the ambition and objective of the tech squad, for instance here, then let's see what the LLM will answer with the contextual element that we injected. And here you can see the text. So the final answer of the LLM is this part. All right. So the text squad is blah, 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 1, 2, 3, 4. And then here you have the source document that were used to make the answer. So you see you have one document here, another one here. You have 4 of them because it's the default value. All right. So nice. Here you still have to code, but you see it's a more abstracted level of coding. You know, it's not that much lines of code. But if you don't want to code at all, you can also use level 3 abstraction solutions like Flowise. So Flowise is already covered in a previous video. What I want to do now is just to demonstrate the use of Flowise by hosting it on Hugging Face itself. Because if I go back to my personal space on Hugging Face, there are the concept of spaces where basically it's hosting services dedicated to AI and LLM based application. And I did deploy Flowise on my space on the free tier 1. Here we are. So here you have the UI of Flowise already available. If you go to the file view of my space, you can see it's like GitHub. I just uploaded a Docker file, the Docker file from Flowise, and then Hugging Face automatically built my container and then started it. So you can see the logs of the container here. So if I go back now to the application view, I already designed and configured ChatFlow here based on Falcon. And basically it's the same thing as before, or as what I showed in LangChain code. So I have my conversational Q&A chain here. It's connected to a chat Hugging Face component where I gave my API key here, the name of the model. I have a buffer memory to have the history of the conversation with the LLM. And I have here my in-memory vector store that is connected to the embedding model that I choose again, the same one, BII, BG, small one. And then here is my single PDF file that I want to transform into vectors and inject them in my memory vector store. This vector store is connected to my workflow predefined by LangChain. So it's very easy to graphically, without any code, define some workflows and application. So if I run it, the code here, and I ask my question, what is the tech squad, for instance? Here I have the answer. It's a global community, blah, 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 blah. And then also, because I did check return source document here, you have the chunks that were used, just like before. So here you can see the metadata part of it. So this one or this one. So this is the text that were used to contextualize the answer. So as you see, it's quite easy to play with component offered by Hugging Face. Whether you want to make a direct API calls, use the Hugging Face Node.js libraries, use LangChain or even Flowise. Hugging Face provided a lot of models and components. It's very powerful, so I hope it gave you some insight of what is Hugging Face and how to use it to play and create new applications.
And that's it for now. Keep making wishes, and maybe the GenAI's lamp will fulfill them. Stay tuned. Bye-bye.